The Falcon 9 rocket supporting today's mission is a two-staged rocket designed for the reliable and safe transportation of satellites, cargo, and people. Starting from the very top of the rocket, we have the payload fairing. The fairing is a protective shell that houses all the payloads, shielding them from the aerodynamic heating until the vehicle is outside the Earth's atmosphere. The shape of the fairing contributes to Falcon 9's overall efficiency, helping to reduce drag during flight. Once in space, the two fairing halves separate and fall back to Earth, where they will be recovered by our recovery vessel to be refurbished and reused on future flights. Both halves of this fairing are flight-proven, with one flying for its 23rd time and the other for its second. And within that fairing is today's payload. Here is a photo from midway through the encapsulation operation, just before the fairing halves were closed in preparation for flight. And here is a live view inside the second stage as we await liftoff.
Stage 1 RPM unload is complete.
Right below the fairing is the Falcon 9 second stage, which houses a single Merlin vacuum engine or MVAC engine. Below the second stage is the black carbon fiber inner stage, and the inside of that is where the MVAC engine is located. The inner stage connects the two stages and houses the center pusher that allows the first and second stage to separate during flight. Below that, we have the first stage or booster. The first stage makes up the bottom two-thirds of the vehicle and has 9 Merlin 1D engines at the bottom, which generate more than 1.7 million pounds of thrust. The first stage supporting today's mission will be making its 21st flight today. It's previously supported NASA's Crew 7 mission to the space station and NASA's CRS-29 cargo resupply mission, PACE, Transporter 10, Earth Care, NROL 186, Transporter 13, Tracers, NROL 48, and 11 Starlink missions. In about 2.5 minutes into flight, the first stage will separate and make its way back to Earth. Today, the booster is returning to the launch site, heading to Landing Zone 4 at Vandenberg Space Force Base. Coming up, the truss structure next to the vehicle, which is known as the strong back or the transporter erector, will start to retract. In preparation for retraction, the clamps around the second stage will open, and then the strong back will begin to recline away from the vehicle.
Back retract has started.
You should now be able to see the arms coming open, and it'll take 15 seconds for them to fully open, but once they're out of the way, the strong back will recline back away from the vehicle to give it room for liftoff. Now that those clamp arms are fully open, the rocket is fully free at the top. And there you can see that the strong back has fully reclined.
Stage 1 LOX load is complete.
And there you heard that the Stage 1 LOX load has been complete. Coming up at T-minus 2 minutes, we will have second stage LOX load complete. For those of you who are just joining us, this is the first mission of SpaceX, the COSMO-SkyMed FM3 launch.
Stage 2 LOX load is complete.
And there you heard stage 2 LOX load is complete. And quick correction there, this is SpaceX's first mission of the new year, 2026.
Gas closeouts.
F9 is in startup.
F9 is now in startup. Stage 1 and Stage 2 are beginning to press for launch.
D is go for launch.
There you heard LD is go for launch. At the T minus 30 seconds mark, all systems should be go for launch.
T minus 3 seconds. T minus 15 seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff of Falcon 9. Go SpaceX, go Cosmo. Vehicle is pitching downrange. Stage 1 propulsion is nominal.
At 2 plus 30 seconds into flight, Falcon 9 has successfully lifted off from Space Launch Complex 4 East at Vandenberg Space Force Base in California. We're currently throttling down to prepare for max Q, the point of maximum aerodynamic stresses on the vehicle. Max Q is reached when the air density of the atmosphere decreases faster than the increasing speed of the rocket.
Falcon 9 is supersonic. Q.
And there you heard max Q. From here on, even though velocity is rapidly increasing, the atmospheric density is decreasing, resulting in less loads on Falcon 9. Now we have several events coming up in quick succession, starting with MECO, stage separation, stage 1 flip, second engine start, or SES1, the boost back burn, and fairing deploy.
Cut off.
Separation confirmed.
Back ignition.
And there you heard and saw those 6 events that happened back to back, including main engine cutoff, stage separation, stage 1 flip, second engine start 1, and the boost back burn and fairing separation. The next major milestone coming up is entry burn on our Falcon 9 first stage, which is scheduled to occur just after the T+6 minute mark.
Confirmed.
The entry burn is used to slow the first stage as it heads towards landing zone 4.
Both vehicles are following nominal trajectories.
We're currently in our first MVAC burn, and this burn should last for another few minutes. The next milestone will be first stage entry burn, coming up in a little over 2 minutes. Today's Falcon 9 is performing 2 burns in order to land. The first burn, known as the entry burn, slows the vehicle down before hitting the denser parts of the Earth's atmosphere. Without this burn, we'd only be using the atmospheric drag to slow down the Falcon 9, which would add extra stress to the vehicle. Following the entry burn, the booster will initiate the landing burn, which should slow the vehicle down even more for a successful landing at Slick 4.
Both vehicles continue to follow nominal trajectories.
When Falcon 9 fires up the center M1D engine for re-entry, the vehicle will be flying through Merlin's exhaust gases, also known as the rocket's plume, which deposit a layer of soot on the vehicle's surface. You'll see these marks across the flight-proven Falcon 9 first stage fleet. That soot comes from a carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle. Falcon 9 is equipped with 4 hypersonic grid fins positioned near the top of the first stage that help steer the first stage as it returns to Earth. The white puffs coming off Falcon 9 that you may see on screen are cold nitrogen gas, which helps with altitude control.
You want entry burn startup?
And there was the call out for entry burn startup on the Falcon 9 first stage. This burn is set to last about 30 seconds and again is slowing down the vehicle in preparation for its final burn and landing.
You want entry burn shutdown?
And that concludes our entry burn. As mentioned earlier, we will be attempting to recover this booster. Today, the booster is targeting a landing
Vehicles continue to follow nominal trajectories.
Today, this booster is targeting a landing at Launch Complex 4 West. You can follow along with the burn on the engine graphic at the bottom of your screen. As the burn happens, you'll notice a decrease in both speed and altitude. And this is coming up in about 20 seconds.
Which one FTS is saved?
One transonic. Stage 1 landing burn.
And there you heard the call out for landing burn start on the Falcon 9 first stage. Again, this is the final burn that this booster will execute before landing.
Stage 1 landing leg deploy.
And as you saw and probably heard, we had a successful first stage landing. Coming up next, we are expecting the shutdown of the second stage MVAC engine. This is known as second engine cutoff 1 or SECO 1. Now, if you're just joining us today, we have had a successful launch and landing of our first stage Falcon 9 booster. This is for the COSMO-SkyMed FM3 mission. Coming up in about 20 seconds, we have
2 FTS
SECO 1 or second engine cutoff 1.
Stage 2 has entered terminal guidance. Back shutdown.
And there you heard a successful cutoff of our second stage engine and waiting for confirmation of good orbit.
Nominal orbit insertion.
And there we heard the call out for good orbit. Payload deployment is now coming up in just a few minutes and is expected just before the T plus 13-minute mark. It has been a great launch and overall mission so far. We have had an on-time liftoff at 6:09 p.m. Pacific time, and we recovered the first stage for its 21st launch and landing. The MVAC engine on the second stage ignited just a couple minutes after liftoff, also known as Second Engine Start 1 or SES1. That engine burn lasted about 8 minutes, propelling the second stage and our payload to orbit. And coming up, the most important milestone for the mission, payload deployment, which is expected just before the T plus 13-minute mark. COSMO-SkyMed is a dual-use civil and military Earth observation program sponsored by the Italian Space Agency and the Italian Ministry of Defense. For almost 20 years, COSMO-SkyMed has been observing the Earth using advanced radar technology capable of operating day and night in all weather conditions. The system provides critical data for environmental monitoring, climate studies, security, emergency management, and protection of land, marine, and coastal areas. The constellation currently consists of 4 fully operational satellites, 2 first-generation satellites, and 2 second-generation satellites. With today's launch, a third second-generation satellite will join the constellation. The addition of COSMO-SkyMed Second Generation FM3 will expand data availability and improve monitoring capabilities with tangible benefits for society, from safety and emergency responses to environmental sustainability.
Load separation confirmed.
And a successfully deployment of COSMO-SkyMed.